Hello, good evening all of you. Audio video clear? Please mention whether the audio video is clear. Hello. Okay, so let's start. Today's topic is anagrams and number rearrangement. So this is part of the permutation combination unit. So please try to invite your friends also to be part of this lecture. The link is there in the live chat and in the comment section. So in this course, we are covering all topics of UPSC CSAT, and this course is useful for CSIR NET, GATE and other exams also. So you can invite all aspirants to be part of this lecture or this course. To the new students, my name is Christy Varghese. More about me you can see here, and these are the books I have written. And if you want our flashcards or if you want to join our courses, you can check it out in the mobile application Christy's classes. In the description of the video, you can find the links. For CSIR NET, for GATE, we have already the full courses. For UPSC, in the future, we will be having courses in this platform. So if you want to get updates of all our free resources and upcoming live lectures or free lectures, you can be part of our website christyvarghese.in, Telegram channel, WhatsApp group and mobile application Christy's classes. Check the description of the video to get all the links. And check out the other playlists in this channel. Those of you are new to this channel, hit the bell icon and the subscribe button so that you will get update, so that this community also grows daily by more and more people getting added to this channel. Okay, so let us start. Today's topic is anagrams and number rearrangement. So last class we discussed about fundamental principle of counting. I hope all of you remember what is fundamental principle of counting. We discussed this example, and this example shirt and pant. 3 shirt and 4 pant means 3 into 4, 12 combinations are possible. So this basic idea is needed in today's chapter also. Fundamental principle of counting is the base of all permutation combination questions. So today we are discussing anagram problem, means letter rearrangement problems are called, or letter rearrangement are called anagrams. For example, if you write the letter, say THE, if that is a word, if you rearrange it and write HET, that is THE rearranged to form HET. So that is another anagram of it. So rearranging a word is called anagram. So how many possibility? So I will explain this with the basic question, the concept of anagrams, and then we will derive formula also for that. So make a try this question, all of you. After learning the concept, we will start the previous year questions also. All of you make a try. Yeah, you don't need any theory to do this. It is a very small word, so you can write it down and find how many arrangements are possible. So that is what I asked. I didn't ask you to try a question without learning the theory. This is so simple, na? ANT, 3 letters only. 3 letters, how many ways you can rearrange? So you can start with the first letter. So if I take ANT and write it down, that is a word. ANT is a word. And now what I can do, I can fix this first letter, write it down, and N and T can be rearranged to form T and N. Now all combination with A as the first letter is done. So combination with N as the first letter, I can write now NAT and NTA. So 2 possibility for N in the beginning. And similarly, T in the beginning, TAN and TNA. All of you are understanding? And these are the only possibility, or these are the 6 arrangement possible. All of you understood this? In this case, as it is a small word, you could have written, you can write it all possibility, that was okay. But if it is a bigger word, it is not feasible. No? For example, if you take the word FOUR, what will happen? Can you try, all of you, the same way you did the previous question? Can you try this? When you try it, you will understand this logic clearly. I'm now going to extend this and make a general form or general formula for this. Instead of by hearting the formula, let us learn the concept so that whatever way the question is asked, you will be able to do it easily. Very good. Some of you got an answer. So due to lack of time, I will explain it. First, we will observe what happened here. First, we fix the first position. Na? Like we discussed in the fundamental principle of counting chapter, this first position have how many choices? The choices are A or N or T. So 3 choices are there to fill the first position, na? The leftmost position. Now that letter is available only once. That cannot be repeated anymore. That means here 2 possibility only remaining. Or look at this. When you fix A here, A is not available anymore. So the second position can be filled with N or T. 2 ways only. When you fix A also, N also, T also, that is the case. Na? So for each of these 3 cases, 2 possibilities are there for the second letter. And similarly, when you fix the first and second letter, remaining 1 position only have 1 way of filling it. Na? Only 1 way of fixing it. That is 1 way. Fundamental principle of counting, when you apply, M ways to do one thing, N ways to do another thing, P ways to do another thing, then M into N into P ways to do all together. And that is what we mathematically call as 3 factorial. In case anyone is not aware about 3 factorial or what is factorial, factorial just means multiplying till 1. If it is 3 factorial, it is 3 into 2 into 1. 4 factorial is 4 into 3 into 2 into 1. 5 factorial is 5 into 4 into 3 into 2 into 1. So anyway, 3 factorial. So similarly, in this question, 4 letter word 4, how many ways will be there? 4 ways to fill this, 3 ways to fill this, 2 ways to fill this, 1 way to fill this. So 4 into 3 into 2 into 1, 4 factorial. So if n letters are there, n factorial will be the answer. Na? Or in general, I can say, if all n letters are different, number of arrangement will be n factorial. N distinct objects can be arranged in n places in n factorial ways. 4 distinct objects, 4 places, so 4 factorial. In the previous question, 3 different distinct objects, 3 different places, 3 factorial. So what is the relevance of this word distinct? I will show you another question to explain that idea. Try this question, all of you now. Same idea question. All of you make a try super fast. And those of you are watching, if you are feeling that this session is useful for you, do hit the bell icon, hit the like button. So, and do share it with your friends also. All of you try this question. 6 letter word. So what will be the answer? Okay, so I'll explain. Different answers I can see in the chat. Yeah, by the theory we learned in the previous question, 6 letters can be rearranged in 6 factorial ways. Na? CHANCE is 6-letter word, so 6 factorial normally, that is 6 into 5 into 4 into 3 into 2 into 1. When you multiply it, you will get it as 720. But 720 is not the correct answer. Why? Because I told you, if distinct objects are there, then you can apply that theory. Distinct means all letters should be different. If it is not different, let's see what happened. ANT, I will use another word, NNT. Instead of ANT, if it was NNT, will the answer be same? Think about it. Same question, but instead of ANT, it is NNT. So I fix this first N here, then NT I can write here, TN I can write here. Next, when I try to fix the second N, first N and second N looks the same itself. Now, that is not different letters. That is the same letter. So NNT and NTN are just duplicates of this and this respectively. So this is not new combination or not new words. That is the same word itself. Same way when you try to write the remaining words, if you fix T in the first, TNN is okay, but then rearranging the other N, TNN, that is not a new word. So out of the 6 words, half of them are duplicates. Are you all agreeing this? If the word was ANT, all 6 were originals. All 6 are different words. Like I discussed in the password question yesterday, if you are entering these as passwords, all of the passwords are different. But in the case of NNT, if you rearrange NTN, NNT, NTN, TNN, TNN. When you write it, you are thinking that this is N1, N2, first N and second N. This is first N, second N. This is second N, first N. But the word is the same itself. No? That is why this is duplicates. NNT is duplicate of this. NTN is duplicate of this. TNN is duplicate of this. So only half are originals, half are duplicates. Or in other words, this N and N can be rearranged among itself in 2 factorial ways. So you have to divide by 2 factorial. 2 factorial is 2 itself. That is why I said half of them are originals. So if it was NNT, it is 3 factorial 6 divided by 2 factorial. All of you understood this theory? Please respond. Or in general, we can say, out of n objects, A objects are similar, then you have to divide by A factorial. Another B objects are similar, then you have to divide by B factorial, and so on. So now can you think about this question of chance? Chance is a 6-letter word. 6-letter word can be rearranged in 6 factorial ways, agreed. But this C and this C are same. 2 letters or 2 factorial you have to divide by. So 6 factorial by 2 factorial, 720 by 2, 360 is the answer. All of you are understanding? Please respond, is this clear or not? Now let us extend this theory. I am trying to give you complete theory of anagrams so that whatever way the question comes, you should be able to attempt. I will show you a question, that is when you will understand how all they can twist the questions. The idea what I just told you now is enough, but the way the question is asked, that you need to understand properly. Okay, so this is clear to all of you. Very good, perfect. So now what about the other cases of this? So what I just told you now is this n factorial by a factorial or n factorial by r factorial. So c occurring twice, so you divide by 2 factorial. 6 factorial by 2 factorial. What if I will take another example? Instead of CHANCE, if it is CHANCN, sorry, CHANCC, CHANCC, if you consider a word, how many rearrangements will be there? If you don't get the answer also, just tell me the expression. What factorial by what factorial? That is what I am asking. Here CCC, 3 letters, na? 3 letters can be rearranged in 3 factorial ways. So you have to divide by 3 factorial. 3 factorial is 6, na? Or you can say, rearranging C's, you will get 6 duplicates. or 1 original and 5 duplicates. For each of the combination, 5 duplicates are there, or in other words, only 1/6 are original, remaining 5/6 are duplicates. Or if you are not understanding that logic, basically you have to divide by 3 factorial because C is 3 times. So you divide by 3 factorial. All of you understood? Don't divide by 3. In the case of 2 factorial and 2, both are equal. But in the case of 3 factorial and 3, they are not equal. So 6 factorial by 3 factorial will be the answer. All of you understood? What if the word is CHA and CN? CHA and CN means C is occurring twice, N is also occurring twice. So what you should do? Should you divide by 4 factorial? Wrong. You should not divide by 4 factorial. For the 2 C's, you have to divide by a 2 factorial. For the 2 N's, you have to divide by another 2 factorial. So it is 2 factorial you have to divide by. 6 factorial because CHA and CN is 6-letter word. C is 2 times, so you divide by 2 factorial, 2-letter 2 factorial arrangement. N is 2 times, so you divide by 2 factorial again. So 6 factorial by 2 factorial into 2 factorial will be the answer. This is the different ways the same question can be asked. Is this clear to all of you? Please respond. Or in general, this is the general formula we can say n factorial by a factorial into b factorial into etc. In the word CHANCN, n is 6, so 6 factorial. A is number of times C is occurring, so 2 factorial. B is how many times N is occurring, so 1 more 2 factorial. If one more word was repeating, you have to divide for that number also. Is it clear? Super easy, na? So that is the basic idea of anagrams. So CSIR NET aspirant, this was a previous CSIR NET question itself. To make you understand the concept, I have taken this itself. In UPSC, this was the question asked based on this theory. This just straightforward, what I just discussed now is asked. But one small twist, by adding extra information, they are trying to confuse you. Once you identify that, it is super easy. All of you try this. (2020) PYQ. So just like in fundamental principle of counting, we identified the positions and tried to fill it. Same idea itself. But here you can directly apply the anagram formula if you want. So due to lack of time, we'll start explaining. Many of you got the answer right. Wonderful. How many different 5-letter words can be constructed using with or without meaning? If it is not mentioned also, it is with or without meaning. Can be constructed using all the letters of the word Delhi, so that each word has to start with D and end with I. So there is a constraint that first letter should confirm be D, last letter should confirm be I. That means that positions are already fixed. Don't worry about that 2 positions. So we only have to worry about the remaining 3 positions. What all are the letters available? E, L, H. Are they all distinct? Are they all different? Yes. 3 letters, 3 different positions. So 3 factorial arrangement, or 3 into 2 into 1 arrangement. Na? So 6 arrangement. If you are not clear about it, these are the 6 arrangement. ELH, EHL, LEH, LHE, HEL, HLE. It is literally the same question I explained. The word rearrangement of and. Same question itself. Instead of and, it is ELH. But just to make you think about the question more, they have added extra decorations telling like first letter D, last letter I. Shanti, can you please specify where you have doubt? Because we have to cover a lot of topics today. I mean number rearrangement also after this. So if you can specify the doubt, I will definitely repeat that part. Okay, all of you, is it clear? Please respond. Then I will show you little more trickier PYQ that was asked, even that was asked in 2023. To show you such a question. which was not directly asked, but the clue I can give you is the theory I taught you now is enough to do that question also. Just a minute, I'll show you that question. Just a minute. Okay, that is in number rearrangement. I will explain about number rearrangement, then we will discuss that question. That will be better. Shanti, in CHA and CC, C is occurring how many times? 3 times now. If 3 times, you have to divide by 3 factorial. That is the trick. 3 times means you have to divide by 3 factorial. 4 times C is occurring means divide by 4 factorial. 5 times means divide by 5 factorial. That is the theory. Is it clear? So now what we discussed was letter rearrangement. The same way numbers can also be rearranged. Number rearrangement also can be done. Number rearrangement means that can have different cases. Due to lack of time, I will start with PYQ itself. This is a one simple version of it which was asked in 2017 PYQ. All of you make a try. It's a number system based problem also, but this idea of number rearrangement is needed to do this question. Try this question, all of you. Okay, I'll explain how many numbers are there between 99 and 1000. Numbers between 99 and 1000 have a speciality. They all are 3-digit numbers now. So indirectly they are saying how many 3-digit numbers are there such that 8 occupies a unit place. Just like the previous question. In previous question, first letter and last letter is D and I fixed now. Same way, last position is fixed with 8. That is already fixed with 8 means there is no other way. There is only one way to fill that. 8 only is the way. So the available positions are only these two where we are allowed to fill numbers. Now, as it is numbers, you have to understand if you put 0 here, that is not a 3-digit number. Na? For example, 018. That is a 2-digit number. That is not between 99 and 1000. So there is a constraint that leftmost digit cannot be 0. Leftmost digit can only be 1 to 9. 1 to 9 are 9 possibilities. Na? 9 possibility. This is not 8 possibility. 8 is the only possibility. That is the meaning of this 8. So 9 possibility to fill the hundreds place or leftmost place. But here you can put 0 also. Na? For example, 108 is okay. 118 is okay. 218 is okay. Etc. Sorry, 108, 208, 308, etc. are okay. Middle you can put 0 also. So 0 to 9 are possible. So 10 possibility. So 9 into 10 into 1 possibility. So here you cannot directly apply a formula. According to the question you have to decide what to fill, where to fill. Again, fundamental principle of counting is the basic idea. Any doubts, please ask. Is it clear? So number rearrangement, that was a simple case. Let us go for a little more trickier case which was asked in 2023. So make a try, all of you. The clue I can give you is compare it with that theory I taught you for chance. I first explained about chance, then I explained about CHA and CC, then I explained about CHA and CN. Those idea if you apply, you can do this question super easy. The problem is many people don't connect these ideas. They think that these all are different concepts or different formula. First thing you need to unlearn is that it is not about by hearting too many formula. It is about the concept. It is all basic fundamental principle of counting theory, nothing else. This chapter, next chapter, this unit of permutation combination, if you understand, it is nothing but fundamental principle of counting. It is easy actually. Repetition allowed or not, in rearrangement, the numbers available you have to use now. So it is clear now, Samia, that numbers only can be used. So repetition means if numbers are repeated in the set, for example, here 1 is 2 times, then 1 can be used 2 times, but 1 cannot be used more than 2 times. That is the meaning. So it is arrangement. So generally repetition is not allowed. It is not like 1 can be used infinitely many times or 1 can be used in all position. No. Because we are not asked to pick numbers from somewhere. We are only asked to rearrange the numbers or digits. Any idea? Some of you got an answer. Okay, just wanted to know here, students preparing for other exams, which all exams are there? I know my classroom coaching students of Lead IAS is here. Other institute students are there. Because I teach in different institutes, so students of any other institutes are there. If you can let me know, that will be good to know. So yes, Rajan, the book is available in Amazon and Flipkart. In bookshops, I don't know which all bookshops. You can check with the publisher. The name of the publisher is Scientific Publishers. Okay, so this question, due to lack of time, I will start explaining. Some of you already got the answer. Thus, if you have doubt, listen very carefully. How many distinct 8-digit numbers can be formed by rearrange the digits of the number 1, 1, 2, 2, 3, 3, 4, 4. Let me convert this question into another question. First of all, if this condition is not there, and if it was C, C, D, D, E, E, F, F, what will be the answer? Can you tell me that? C, C, D, D, E, E, F, F. ये word कितना तरीके से rearrange, sorry, this word how many ways you can rearrange it? 8-letter word na, so 8 factorial rearrangements, and C is occurring 2 times, so you have to divide by 2 factorial. D is occurring 2 times, so you divide by 2 factorial. E is occurring 2 times, you divide by 2 factorial. F is occurring 2 times, so you divide by 2 factorial. That would have been the answer if this condition was not there. This would have been the answer even if C, C, D, D, E, E, F, F, F are not there. Even if it is 1, 1, 2, 2, 3, 3, 4, 4, then also the answer will be this. First of all of you understood that thing. This concept is analogous to this anagram idea itself. Did you all understood that? Instead of letters, it is numbers. That's the only difference. But there is an extra condition such that odd digit occupy odd position, even digit occupy even position. So that condition should be satisfied. So if the question was still here only, answer would have been 8 factorial by 2 factorial, 2 factorial, 2 factorial, 2 factorial multiplied. But due to this extra condition, what we need to do, you have to think about odd position and even position. 8 places, odd positions means what? Odd positions means unit place, hundreds place, 10,000s place, or 10 lakh place. Or these are the odd positions. O for odd. These are the odd positions. Odd positions, odd digits should occupy odd positions. Odd digits are 1133 ना. ये 1133 सिर्फ odd positions में fill करना है. 4 positions है ना. 4 position है, 4 digits है. Sorry, let me switch to English only. So 4 positions and 4 digits are there. So how many ways you can rearrange? 4 factorial ways. but 1 is occurring twice, 3 is occurring twice. So to fill the odd positions, there is 4 factorial by 2 factorial, 2 factorial ways. All of you understood this? Please respond. 4 factorial by 2 factorial, 2 factorial ways. Is this clear or not? For odd position filling only, consider odd positions are as a set of letters itself. 4 letters, 4 odd positions are there. Na? How many letters are available to fill? 1, 1, 3, 3, because that are the only odd digits available. Odd digits should occupy odd positions. Na? So these 4 digits should fill these 4 positions. Odd, 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 odd. 4 positions, 4 digits means 4 factorial normally, but 1 is occurring twice, so you have to divide by 2 factorial. 3 is occurring twice, so you have to divide by 3 factorial, 2 factorial again. All of you understood how to fill the odd positions? Now how to fill the even positions? Think about the even positions. Same logic itself. Now 4 even positions are available, 4 even digits are available, and 2 of them are repeating twice. 2 and 4 are repeating twice. So same logic, even odd position fill this many ways, even position filling also 4 factorial by 2 factorial into 2 factorial ways. So that is why odd position and even position filling, fundamental principle of counting if you apply, 4 factorial by 2 factorial, 2 factorial into 4 factorial by 2 factorial, 2 factorial, that is 6 into 6, 36 ways. All of you understood? Those of you have doubt, please ask. I will explain that part. Okay, yesterday I told you why we need fundamental principle of counting. Because manual counting is time consuming. But when you practice, you can start manual counting to understand the concept better. This 1 and 1, 3 and 3 can only occupy odd position. Na? So if you identify the odd positions are these 4. So I can put 1 here, 3 here, 3 here. Na? What all other rearrangements are possible? 3, 1, 1, 3. Sorry, 3, 1, 3, 1. 3, 1, 1, 3. Now 1 in the first position. 1, 1, 3, 3. 1, 3, 1, 1. Sorry, 1, 3, 1, 3. 1, 3. 1, 3, 3, 1. These are the 6 possibility. That is the 6. But writing all this is very time consuming. That is why we need a principle of counting. That is why we introduce fundamental principle of counting. So as I told, it is just a simple story. The problem is we are hearing it from in between. We are not getting the full connection. That is why I first explained yesterday about fundamental principle of counting. Those of you missed yesterday's lecture, I strongly recommend watch that recording. Then you will get many of the things cleared in this session also. Okay, so instead of writing this, we told that 4 factorial ways to fill odd positions, because 4 odd position, 4 digits are available. If all of those digits are different, 1357 for example, 1133 instead of it was 1357, then it would have been 4 factorial itself. 4 factorial itself, because 4 digits, 4 positions. But here 1357 all are different, but here as I told you the theory, if one letter is occurring 8 times, you have to divide by a factorial. Na? You have to divide by a factorial. Another letter occurring b times means you have to divide by b factorial. So that is the reason why we are dividing by 2 factorial and 2 factorial. The idea of this anagrams itself. Here I didn't mention letter, I mentioned objects. Objects means letter or number or whatever it is the same itself. Rajan, the latest edition is 7th edition. It is available in Amazon and Flipkart. Anusha, 6 plus 6 can be done. Okay, let me tell you. Yesterday I told you fundamental principle of counting, multiplication rule and addition rule. Multiplication rule should be applied when this and that should happen. There is no choice that this or that. Or means addition you can do. And means multiplication you have to do. If the question says that you can only fill the odd position and leave the even position, if the question says so, like I am telling that I am only ready to fill the odd positions. So I fill 1 here, 3 here, 3 here. Is this a valid arrangement according to the question? No, right? Because question says odd digits, odd positions also should be filled and even positions also should be filled. And means it is mandatory that both should be done. And means multiplication. Or means addition. Or means addition and means multiplication. I think now it is clear. Yeah, all of your doubts are welcome. If you specify the doubts like this, there will be clarity. Repeating from the beginning, all things will take time. But if you specify doubts, I will be able to answer you better. Okay, so is this clear? So this was a similar question. If you want, you can try. Anisha, that is what I just explained now. Why not 6 plus 6? 6 plus 6 can be done if the question is saying that odd positions or even positions may be filled. But the question says odd position and even position should be filled. Simple rule, and means multiplication, or means addition. It was and in the previous question, that is why it was multiplication. Clear? Trinesh, if you specify the doubt, I will answer that part because I already explained that 2-3 times. If you specify the doubt, I will explain that. Okay, due to lack of time, I will start explaining this also. This also look very difficult, but it is very simple. It is same as previous question. How many distinct numbers greater than 30,000? Greater than 30,000, you can only use 2, 2, 3, 3, 3 means you cannot use 4 or 5 or 6 or 7 or 8 or 9. So greater than 30,000 means 30,000 something only is possible. So the leftmost position can only be 3. That is fixed. You cannot change that. Just like last to last question, this 8 was fixed in the unit position. Here 3 is fixed in the 10,000th position. 10,000 position. So 3 means among these 3 3s, 1 3 is already fixed. You cannot change that. You cannot take that 3 anymore because it is already fixed in a position. Na? That means the remaining 4 numbers are available. And how many positions to fill? 4 positions. 4 numbers in 4 position, 4 factorial ways normally. But this 2 is repeating. So 2 factorial you have to divide by. 3 is repeating twice. Don't count the third 3 because that already have a purpose to fill the 10,000th position. You cannot take it anymore. Because if you take it, you have to replace it by something. Na? What you can replace? The only available number is 2. If you fill 2, that is not a number greater than 30,000. Yeah, your basic understanding of digits and place values is needed. Digits and place values already we covered in this course. Those of you missed it, you can check out in the number system unit. I think it was a second lecture in this course. So anyway, 2 factorial you divided by 1 more 2 factorial for the next 2 3s. So 4 factorial by 2 factorial by 2 factorial. That is 24 by 4 because 24 by 2 into 2. That is 24 by 4, 6. And if you are curious to see which are those 6 numbers, these are the 6 numbers. When looking at these 6 numbers, you may get little more clarity. Yeah, here I agree. If you want, you can write the 6 numbers. That way also you can finish the question. Because the numbers are only 6 in number. But in previous question, 36 numbers writing down is not practical at all. That was the latest PYQ. That is why we had to use this idea. In this question, if you want, you can write like this also, no problem. Anyway, all of you understood this? So anagrams and number puzzles are all same idea itself. This is just an extension of that. You can try this. Other similar questions from other exams also, I will share it in the group. Those of you in the Telegram channel. Those of you are not part of our Telegram channel, if you are being part of it, you will get the daily practice questions of each chapter. For UPSC, there's a separate Telegram group. For CSIR and GATE exams, there is another group. The links of both are available in the description of the video. So all clear? Yeah, I like to hear from all of you whether this lecture or this course is making an impact. So as I told, that will keep me motivated to give better content. Rajan Arya, thank you so much for the good words. Thank you so much. So this is the basic idea of anagrams. So this basic idea, if you look at it, all questions we have done in this chapter based on this single theory, not 10 formula or 100 formula, just one single, not formula, a concept, n factorial by a factorial into b factorial into etc. Clear? Thank you, Samia. Thank you for the good words. So tomorrow we will be discussing permutation combination formula. What is permutation combination formula and which question should be done with the permutation combination formula, that also we will be discussing. Thank you, Avanish. Thank you, Anshika. Yes, Shruti, UPSC aspirants, I clearly know your situation. That is why I don't want to burden you with a 1 hour lecture or 1.5 hour lecture, because now every minute counts. Okay, the lecture is over. Those of you are preparing for UPSC because your exam is nearer. Other exams is like 2 months, 3 months away. The class is over. Those of you want to leave can leave. Those of you have any doubt, you can ask. So tomorrow we will be discussing when specifically you have to use permutation formula, when specifically you have to use combination formula. Samia, in this course probability is not included because in UPSC topics probability is not asked. So UPSC we will be that is why probability we will be discussing as a separate lecture. Rajan, my native is Kerala, but I am staying in Bangalore. Okay, so I think let's conclude if there is no other doubts. So that's it, and please practice the questions I am sharing also. 10 questions we are sharing every day, and try those questions, and those of you are part of our Telegram group, you can post your doubts there also. I will try to answer it whenever I get time. Okay, that's it. Thank you all of you. CSIR NET aspirants, if you want to be part of our full-length course, this is the details of the full-length course. CSIR NET Part A complete course. Recorded video course with 55 recorded videos covering complete theory, previous year questions and practice questions. And online study materials will be there: 100 flashcards, 50 topic wise PDF, 50 practice worksheets and test series. And the course will be accessible in laptop and mobile. And the teaching language will be Hindi and English. So CSIR NET aspirants, this course you can follow. For GATE, we will be coming up with a course starting from most probably June or July. So that also you can join if you want for 2025 GATE. And UPSC aspirants, the flashcards are available in the mobile application Christy's classes. For CSIR also the flashcards are available. So that's it. Check out our mobile application also. We update regular study materials in the mobile application also. And Amiga, the link is there in the description of the video. Join the channel. There is a associated Telegram group, discussion group. You can join directly from there. So that's it. Thank you all of you. Thank you all of you for the support you are giving for this initiative, because daily more students or new students are joining. That is definitely a encouraging thing. Thank you. Take care. Bye bye. Have a good night. See you all on the next class, and do like the video, do comment on the video, and do share the video to maximum people. Tomorrow 8:30 p.m. will be the next lecture, permutation combination.